we have learned an activity in which we have a current carrying rod AB that experiences a force perpendicular to its length and a magnetic field. Now we are going to learn how to find the direction of the force on the conductor. For that, we have to learn Fleming's left hand rule. Students, previously we have also learned right hand thumb rule, and now we are going to learn Fleming's left hand rule. The activity which we learned before, there we considered the direction of the current and that of the magnetic field perpendicular to each other, right? The direction of current and direction of magnetic field are perpendicular to each other, and they found that the force is perpendicular to both of them. So keeping these three things in mind, we can give illustration for the direction by using Fleming's left hand rule. What is this rule? According to Fleming's left hand rule, stretch the thumb, forefinger, and middle finger of your left hand. How? You can stretch this thumb, forefinger, and middle finger of left hand in such a way that they are mutually perpendicular to each other. So, as shown in the figure, stretch your thumb, forefinger, and middle finger of your left hand. How? So as they are perpendicular to each other. And then consider that the first finger, forefinger, points in the direction of magnetic field. Middle finger is in the direction of current. Then the thumb will point the direction of motion. Or here, what do we consider? The force acting on the conductor. Why is it said that motion? Because we know when the force is exerted, the rod displaces, which means it will change its place. And when we know that when the thing changes its place, we can say that it is in motion, right? It has displaced. That is why force or motion, both things will consider the same. When there is force, then only the rod will displace. That will be in motion, right? So this way we'll consider the forefinger represents the magnetic field, the middle finger represents the direction of current, then the thumb will represent the force or motion. So, if we want to know the direction in which the rod gets displaced, or if we want to know in which direction the force has exerted, then how will we find? By using Fleming's left hand rule. For that, we must know two things: magnetic field and current. If magnetic field is in upward direction, the middle finger shows direction of current, then thumb will show the motion, the direction of motion, or the direction in which force is exerted. So by using this rule, we can find the direction of motion. So according to the situations, you can keep your left hand in such a way that you can find the direction of motion or the force acting on the conductor. But you need to keep that in mind that you stretch your fingers in such a way that they are perpendicular to each other. Then only you will get the right direction. Okay? Students, here I want you to recall right hand thumb rule. Do not mix both the rules. What is right hand thumb rule? It is When we imagine that we are holding a current carrying straight conductor in your right hand, then the thumb points towards the direction of current and the fingers are in which direction, that shows the direction of the magnetic field. So this right hand thumb rule we use for what? To find the direction of magnetic field which is associated with the current carrying conductor. Please remember this right hand thumb rule is used to find the direction of what? Magnetic field which is associated with a current carrying conductor. Whereas Fleming's left hand rule is used to find the direction of the force exerted on the conductor. Please remember this. Remember the difference between the uses of right hand thumb rule and Fleming's left hand rule. Okay, students? So, this is all about force on a current carrying conductor in a magnetic field and Fleming's left hand rule. The devices that use current carrying conductors and magnetic fields are electric motor, electric generator, loudspeakers, microphones, and measuring instruments. So, in the next sessions, we will study about electric generators and electric motors. This is all about today's session.